Hello everyone, and welcome to another part of the Unity scripting tutorial. In this video I want to talk about terrain generation, and more specifically we're going to be looking at the Diamond-Sqaure algorithm to generate a procedural terrain. For this video you will need to know how to create a custom mesh in Unity, and if you don't know how to do that, I'll link one of the previous tutorial videos that explains how to do it. But if you already watched it, we can go ahead and get started on this video. So what you will need is an empty game object that has a mesh filter and a mesh render attached to it, as well as a material. Once you have that going, we can just create our new script, and let's call it Diamond-Sqaure terrain. Here we go. And once we have that, we attach it to our object and then go ahead and open that script. So let's have a look first at the Wikipedia page about the Diamond-Sqaure algorithm to see how it actually works. As you can see here, the Diamond-Sqaure algorithm always has to have a height of the width and height of 2 to the n plus 1. So for example, you have 5 vertices and 5 vertices for width and height, and that makes about 4 faces for width and 4 faces for height. So let's get started from there, and let's create our first variable. So let's make a public int, and let's call this one mDivisions, and this will pretty much contain the number of divisions that it has. I find that looking at the verts is much harder than just looking at the faces, so the divisions will be the number of faces that you have, which will be 4, for example, for this one right here. So once we have that, we can go ahead and give it the size as well, which is a float, so mSize. This will be the size of our terrain, so it will be a square in the world that's, let's say, 10 by 10 or whatever we give it. And also we will give it a float, which is the mHeight, and that will hold the max height for our terrain. Okay, so now that we have all our variables set, well, all the public ones at least, we can go back to Unity and we can assign some of these values. So for the division, let's just start with something very small. So let's start with 2. Let's have the size around 5, and let's set the height to 1, and that should be good enough for now. Let's go back to Visual Studio again, and in this one we will need a vertex array, vector 3 array, just like the previous video and everything. So let's get started here by creating a vector 3 array and call it mverts. That will hold all our vertices for the terrain, and an integer for the vertex count, so that will be mvert count. We probably won't need this update function right here, and just to keep everything a bit cleaner, we'll just make a new function, void create terrain, and we'll just call that function in the start, just so that we don't clutter up the start function. There we go. Okay, so first off, we need to know what our vertex count is, and if we go back to the Wikipedia page, as you can see, if we have 4 faces, we're gonna have 5 vertices, and so it's going to be 2 to the n plus 1. So for example, if we have 4, it's going to be 5 by 5, so the vertex count will be the mDivisions plus 1 times mDivisions plus 1. There we go. And this is it for our vertex count. We also need to initialize the vertex array. So this is going to be a new vector 3 array. The size of the array will be our vertex count that we just calculated. We will also need the UVs for that, so let's create a vector 2 array and call that UVs, which is going to be equal to the new vector 2 vertex count. So this, because UVs and vertices, each vertex needs a UV, so it will be the same amount. And finally, we need the triangles. So the tries are going to be equal to, oops, it needs to be an array of ints, and the tries will be equal to a new int array. So the number of tries is interesting because, as you can see here, we have the number of faces is the division times the division, and the number of triangles is 2 times that, so it's the m divisions times 2. But as you know, in Unity, tries are defined by 3 numbers. So even though we need m divisions times m division, so if we have m divisions times m divisions times 2, that defines how many triangles we have. But since each triangle is defined by 3 numbers, we need to multiply that by 3. So it's going to be times 2 times 3. Well, or we can just replace it by a times 6. So that's the number of tries that we're going to need for each terrain. Just so that we make things a bit easier for ourselves, these are some variables that we will need later on. So this is half the size of the terrain. We will be using that in just a bit. So this is going to be the size times 0.5. And also each division size, so the size of each one of these small squares. So the division size will be the size, our total size, divided by the number of divisions. Okay, so let's get started now and create our mesh. So mesh is going to be equal to a new mesh, and get the component from the filter. So mesh is going to be equal to the new mesh that we just created. And now we need to make the loops so that we can put in the vertices into the world. So for this, we will need a nested for loop. So for int I equals 0, I is less than or equal to m divisions. Just keep in mind it has to be less than or equal to m divisions, because our divisions are the number of vertices minus 1. So that goes all the way up to 4. So from 0 to 4, which is 5 vertices each. I++. And we will also need another for loop in here, and j equals 0. J is less than or equal to divisions as well, and divisions. And then j++, because our terrain will be a square, so it will always be just the same for these two. Finally, we can set up our vertex positions. So for that, we can do mverts at I times m divisions plus 1 plus j. And if you don't understand why that's the case, it's just that we're using a single one-dimensional array to represent a two-dimensional matrix. So as you can see here, from here it's 0, and then 1, 2, 3, 4, and then once we go down 1 row, it's the number of vertices that we have. So this is number 5. So once you go to I equals 1, you go down 1, so it's divisions plus 1, which is going to be 5, and so on. So this is just a way so that we can represent the vertices as a one-dimensional array, but since we're building up a two-dimensional matrix, it just works out that way. So inverts at I times the divisions plus 1 plus j is going to be equal to a new vector 3. And this will be -half the size plus j times the division size. The height will be 0, and the z will be half the size minus I times the division size. There we go. If you don't understand why this is the case, I suggest watching the previous video on creating custom meshes, but the whole idea is that we just want to, oh, where is that? There we go. We just want to start our mesh from right over here and start building it this way in layer or in rows. Okay, so going back to that now, we just need to set up our UVs. So the UVs at pretty much the exact same thing. So I times m divisions plus 1 plus j is going to be equal to a new vector 2 this time, and it will be a float of I divided by the m division and a float of j divided by m divisions. And all that does is saying that all it does is sets up the UVs so that the UVs go from 0, 0 to 0, 1 throughout the whole terrain, so that it pretty much spreads out one texture throughout the whole terrain. Okay, now that we finished that, we need to build up our triangles. And the triangles are a little tricky. What we will need is another variable up here, and we will call that a try offset. That will just make it a lot easier for us to set up our triangles without keeping track of where we are exactly. So we will need an if statement here. So if I is less than the divisions and j is less than the divisions, we need to build a triangle. And if you were wondering why, is that when we're here, we're setting up triangles. We're here, we're setting up triangles. If we're all the way at the end, we don't need a triangle here. And if we're all the way at the bottom, we don't need a triangle here. So we only need triangles when we're less than divisions and from the rows and columns. And moving on, we will need int top left, and that will be our top left vertex, which will be equal to I times m divisions plus 1 plus j, and int bottom left, which is going to be equal to I plus 1 times m divisions plus 1 plus j. And all these do is that we're just trying to get the index number for the index of, if we're building this face, for example, we need this vertex right here and this vertex right here, and you'll see why in a second. So let's build up our triangles. So tries at try offset is going to be equal to the top left. Tries at try offset plus 1 is going to be equal to the top left plus 1. Tries at try offset plus 2 is going to be equal to the bottom left plus 1. So now that we have our first triangle, so we're going to the top left, and then the top left plus 1, and then the bottom left plus 1. So this is going to be describing our triangle right here. So what we need is this triangle right here. So we will go to the top left, the bottom left plus 1, and then back to the bottom left. So over here, so tries at try offset plus 3 is going to be equal to the top left again. Tries at try offset plus 4 is going to be equal to the bottom left plus 1, as we just said, and the tries at try offset plus 5 is going to be equal to the just bottom left. Okay, and once we're done that, we just need to increase the try offset plus equals 6 because we just filled up from 0 to 6, and then we add another 6 so that we're just filling up all our whole triangle array. Okay, so now all we need to do is just set up our mesh so that we can see what it looks like after we're done all that. So mesh dot verts, vertices is going to be equal to mverts, mesh dot uv is going to be equal to our uvs, and mesh dot triangles is going to be equal to our tries. And next up it's going to be mesh dot recalculate bounds and mesh dot recalculate normals. So pretty much that should be it for just creating a simple terrain, just a flat terrain. So we can go ahead and test that and see if it actually works. Let's see here. We have this right here, so it's a 2 by 2, and as you can see, so there we go. So it's 1, 2, 3, 4. So it's a 2 by 2 divisions terrain. If we increase this by 4, just keep in mind it always has to be a power of 2. So if you're going from 4, you need to go to 8 and then 16 and so on. So as you can see, 4 by 4 and then 8 and so on. It should work up to 128, I believe. I'm not too sure if it actually works with 256. There we go. So 128, that still works. Let's try 256. I haven't actually tried that. Should be interesting to see. Yep, it stops because yeah, the vertices, Unity cannot handle any more than 65,000 vertices, and once you go up to 256, it's way too many for it to handle. But for our purposes, maybe around 64 should be good enough. There we go. So that should be quite dense. Maybe I'll make another video later on, trying to well, explaining how to stitch different terrains together, or multiple custom terrains together, so that you can get a bigger area that you can cover. Okay, so now that we have our terrain, we can go ahead and start our Diamond-Sqaure algorithm. For that, we will go back to the Wikipedia page, and from here, right here, it says that you must first set the corners of the array to initial values, and this is what we're going to do first. So that we need to set our edges of the array to our values. So let's go ahead and do that. Over here, let's say inverts at 0. So because this is our top left corner, is going to be a random.range from negative m height to m height. So we have that. Next up is our top right corner. So as you can see, if the top left corner is 0, the top right corner is the number of divisions plus 1, because the number of divisions, so it's 0, 1, 2, 3, 4. So it's our number of divisions. So let's go ahead and set that. Oh, this one is not liking this. Let's see here. What's wrong with that? Oh, we didn't set it to y. Inverts at 0.y. Okay, and inverts at m divisions dot y is going to be equal to pretty much the same thing, random.range, because we just want to randomize all the corners. So m height and then m height. Next up is m verts. We need now the bottom left corner. And as you can see, it's probably much easier to actually get the bottom right corner because this is just the size of our array -1. So let's go ahead and just do that for now. Verts.length -1 is equal to random.range of negative m height to m height. So we got that. And finally, this one is kind of interesting because you know what this is. And so this is m height -1. So this is -2, -3, -4, and -5. So if this is -5, so it's the -1 minus the number of divisions that we have. And we can use that. So we can just say inverts at inverse.length -1 minus our divisions is going to be equal to random.range from negative m height down to m height. Finally, this is done. Oh, I forgot the .y again. So what we're dealing with here is just the height. So we just need to set the .y for each vertex. Now, if we go back to Unity and we try to run it, as you can see, the heights are raised for each one of these, or lowered. It's just a random between positive height and negative height. So everything is good so far. Now we can start the Diamond-Sqaure algorithm, the actual algorithm that runs through everything. Okay, so I will try not to rush too fast through this. Let me just try to explain how many iterations we need for each square. So if we have a 2x2 square, so I guess something like this one. As you can see, we only need one iteration to do it. If we have a 4x4, we need 2 iterations to do it. That's one. That's a diamond, and then a square, and then another diamond, and then another square. So that's 2 iterations to do it. So when you go through it and calculate it, you'll find out that it's log 2 of the number of faces that you have. And this is what our iterations are going to be. So int iterations are going to be equal to mathf.log of the number of divisions, and that will be log 2. So if you have 8, you would get 3. If you have 4, you would get 2. If you have 2, you would get 1, and so on. So this is the number of iterations that you're going to go through, how many squares you need to divide it down to. Int number of squares, we will use that later. So the number of squares starts at 1, and then we'll increment it as we go. Int the square size, this is the size of our square, how many divisions it is, and of the current square that we're dealing with. So it starts off being a full square, so the full number of divisions, and then it's going to divide down later on. So the number of the square size is going to be m divisions to start off. And finally, let's start our loop. So for int I equals 0, I is less than iterations, and I plus plus. Here we go. Okay, so we need to know where we're starting our row for this iteration. So for example, when you start here, you're starting at the first row and you're going down. And then once you split it up to here, you're starting from this row, doing this square, then this square, and then going down to this row. So you go row by row pretty much for each square. So let's start our row equal int row equals 0. And then we will need another for loop, int j equals 0, j is less than the number of squares that we have, and then j plus plus. And this is what we're going to be using the number of squares for. Finally, in here, it would be int column equals 0 to reset the number of the column number that we're on. And then we will need a third for loop, which would be int k equals 0. K is less than the number of squares, and then k plus plus. If you're trying to wrap your head around why it's 3 nested loops, the first one is the current iteration that we're on. So on the first iteration, it's 1 square for this one, for example. And the second iteration, it's 2 by 2. And that's why we have 2 in here. So second iteration, 2 by 2 squares. And then finally, down here, inside k, we will increment column plus equals the square size. Because if we're in this column and we're dealing with a square of size 2, we jump a square size, so we start doing this one, this square next. Moving on, row plus equals the square size as well. Same idea, if we're here and we need to go down a row, we just go down a square size, which will be right here. And then finally, down here, the number of squares is going to multiply by 2 for each iteration, because first off you start with 1 square, and then you divide down to 2 by 2, and then you go down to 4 by 4 if you have 8 by 8 grid. The square size, of course, the square size, it reduces by 2 it divides down by 2 every time, because you start with 4 by 4 and then go down to 2 by 2. And then height, our height will also go down times equals 0.5f. You can edit this to whatever you want later on. If you don't want your height to go down too fast, or if you want your height to go down very fast, it's up to you. You can lower it to 0.1 or raise it to 0.8. It's up to you to figure that one out. Okay, so now that we have everything set up, let's create our Diamond-Sqaure function. For this function, let's make it down here, void Diamond-Sqaure. And let's set that up with an intro, because each one of these functions, every time we call it, we'll just call it for a single square. So we need to tell it which row that square is on, which column the square is on, the size of the square, and also the offset, which will be how much offset on the height we're going to give it, because we're going to reduce our height every iteration, just to keep track of that. Okay. So first off, we will need half size in here as well. So let's get that out of the way first. So half size is going to be equal to an int of just size times 0.5f. Int top left, which would be the top left index of that square. The top left index of the square will be row times m divisions plus 1 plus the column. Also, int bottom left is going to be equal to the row plus 1. Oh, the row plus the size of the square, because if we go just by 1, we might end up going half a square. So we need to go down by, let's say this is our square, we need to go down, our bottom left will be the entire size of the square, not just 1. Row plus size, and that would be times the m divisions plus 1 plus columns. Okay, so now that we have half the size for our square, we have the top left point of the square and the bottom left point of the square, we need to calculate where the middle point is. And for the middle point, it will be equal to As you can see here, we have it right here, the row, and we have the whole size. So if we have the row plus half the size, we can go down to where the mid is. And then if we have the column plus half the size as well, we can go exactly where it is on rows and columns. And that's what we're going to be doing. So row plus half size times m divisions plus 1 plus the columns plus half size. Again, so row plus half size, so row plus half size, which will give us times the m division so that we can skip all these indices, and then plus the column plus half size. So now that we have where our mid is, we can start calculating what the height value for that mid would be. So m verts at our mid will be equal to. So as you can see here, it's the top left, top right, bottom left, bottom right, all averaged out. So what we need to do is m verts at top left dot y plus m verts at top left plus size dot y plus m verts at bot left plus y at y plus m verts at bot left plus size dot y. Oh, there we go. So now we have, of course, mid dot y. That's the one we want to edit. So we have all these added up. So all we need to do is get the average, and all we need to do that is just multiply everything by 0.25 or divided by 4. But as far as I'm aware, multiplication is much faster than division. So multiplying by 0.25 saves you or gives you a bit of performance boost. Okay, so now we have the average. It also says here plus a random value. We have all four corners plus a random value. And this random value is where this offset comes in. So plus random.range from negative offset to positive offset. There we go. And now we have all our midpoints. So now in here, inside the nested for loops here, right above the column, we need to call our Diamond-Sqaure algorithm. So Diamond-Sqaure, it needs a row, and the row will be just our row, a column, which will be our column, size, which will be just the square size, and finally the offset, which will be our height, because over here we are reducing the height by half, so it will get reduced every time it's passed in. So we have that now, and we have all this. Let's go back to Unity, test it out, and see how it goes. There we go. So as you can see, some of them are raised, some of them are lowered, but there's not a whole lot happening yet, because so far we did half of it, which is just the diamond part. We haven't done the square yet. But at least we know that it works. If you got this far, then everything should be okay. And now we are gonna move on to doing the square part. Okay, so almost there. The square part will be, so we need to get, for the squares, if we know where our midpoint is, we just need to go upwards from there. So our square points will be this one, this one, this one, and that one. So an easy way to do it is our top left point, which we have right here. So we have our top left of the square. If we go by half the size of the square, we get to that point. So, and that's what we're going to do. So inverts at top left plus half size is going to be equal to, and what do we need to average out for this? We need to average out our top left, top right, and mid. And this is what we will do. So inverts at top left, of course it's size dot y. I keep forgetting to do this. Dot y plus inverts at top left plus 1, or plus size, not plus 1, dot y plus inverts at mid dot y. Of course, there isn't really an easy way to multiply by a third, so we'll just go ahead and divide by 3 this time, which should be fine. And then we will add just the random range as well. So random dot range of negative offset to positive offset. Now we have this. We can move on to our next square point, which will go for this one. So this one is our midpoint minus half a size. So this is what we're going to do. So inverts at mid minus half size is dot y is going to be equal to. So what are we averaging here? We're averaging top left, bottom left, and mid. So inverts at top left dot y plus inverts at bottom left dot y plus inverts at mid dot y. And of course we need to average it, so we will divide all that by 3, exact the same way. Random dot range, add the offset to this one as well. And just 2 more to go. So we'll do the right side, which is midpoint again, plus half this time. So let's go ahead and inverts at mid plus half size dot y is going to be equal to inverts. So it's top right and bottom right this time. So inverts at top left plus size dot y plus inverts at bottom left plus size dot y, and finally inverts at mid dot y, divided by 3 to average, and add to it the random dot range of the offset. As you can see, we're just repeating the same step over and over again for each one of these. So finally, the last one is this bottom one right here. So this one, as you can see, is the bottom left plus half the size. So this is what we're going to do, is inverts at bottom left plus half size dot y is going to be equal to inverts at, so it's bottom left, bottom right, and mid. So bottom left dot y plus inverts at bottom left plus size dot y plus inverts at mid dot y, divided by 3 plus random dot range of negative offset to offset. Okay, and I see an error here. Okay, so that's dot y. I put it inside the bracket. So as far as I can tell, this should be okay. Yep, so let's go ahead into Unity now and see what it looks like. Let's try to run it, and hopefully it runs. Whoa, that is really high. Interesting. Let's see what's happening here. Oh, that's not looking too bad. What's going on here? Let's try to increase it to 30 and see what that looks like. Yeah, it is going off the map, and this is why we didn't divide by 3 right here. Hopefully this is it. Oh, there we go. And as you can see, you now have a terrain being generated. If 1 is too low, maybe we'll go for 5. And there we go. Now you have a procedurally generated terrain. Every time you run it, it should be a bit different than the last time. If you go ahead and increase that to 128, you should get a bit more detail onto your terrain. I'll try to do a video about how to texture this terrain. Maybe a shader tutorial on how to color it depending on height and so on. But yeah, that should cover the entire Diamond-Sqaure algorithm. I hope that this video helped. Thank you very much for watching, and I hope to see you next time.